Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA June 2023, Paper 2, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Write 30 to 12 in the form of n to 1. Okay, so when you see a ratio requested in this form with an n here and a 1 here, it means we need to simplify the ratio down, but further than we might normally do. If we cancelled this ratio down using factors, so 30 and 12 share a common factor of 3, or 6 even, so we could divide them both by 6, couldn't we? And that would give me 5 to 2. Okay, but that's not enough. This second number here needs to be 1, even if it breaks that 5 into a decimal number. So actually it's going to be 2.5 to 1. That's the answer. Okay, so 2.5 to 1. So if it does ask for a ratio in the form n to 1, just don't worry if the second one of the parts end up being a decimal or a fraction. Question 2. 4 consecutive triangular numbers are 6, 10, 15 and 21. Write down the next triangle number. Okay, so triangle numbers are numbers where if you take that number of things, you can arrange them in a triangle. So 6 looks like that. 10, if you've ever been 10-pin bowling, you'll be familiar with. 15, if you ever played pool, you'll be familiar with. And so can you see each time we're adding one extra row, and each row we add is one more. So this one has got 6 in 3 rows. You can see that there, and I've added this extra row here of 4 dots, and then this one I've added that row there of 5 dots. So each time you're adding one more, aren't you? So that's add 4, add 5, add 6. So the next one is going to be add 7, isn't it? So the next triangle number is going to be 28. Question 3, write down the reciprocal of 4/7. Now, a reciprocal of a number is the number that you need to multiply it by to get 1. That's the definition of what a reciprocal is. So what we need to multiply 4/7 by to get 1? Well, you just need to flip the fraction over. So write the numerator as the denominator, the denominator is the numerator, because if you did do that, 7 over 4, then obviously 4 divides by 4 leaving you 1 and 1, and 7 divides by 7 leaving you 1 and 1, and multiplying them together gives you 1. So 7 over 4 is a reciprocal. Question 4, the price of a toy increases by 12.5% to £19.53. Work out the original price of the toy. Okay, so I'm going to do this with the triangle FOM. Stick your thumb on it, and then try and work that out. So what have I got from the question? I've been given the percentage change, even here, isn't it? It's increased by 12.5%. So if you've got 100% and you add on 12.5%, that's going to give you 112.5%, which is a decimal multiplier, is 1.125. Okay, so I've got that's my multiplier I've been given, 1.125. Right, now what's this one? Is this the final or the original price? Okay, so we need to decide between final and original here. Well, as it's saying, work out the original price. I guess the original price is the one we don't have. So that's that one. And then the final then is going to be the £19.53. Okay, so this is what we call a reverse percentage question. Okay, so once we've identified FOM, we stuck at the thumb on the one we want to find, which in this case is O, cover it up, and it tells me what to do with the other two. So original equals final over multiplier, which is 19.53 divided by 1.125 then. So I reach for a calculator. 19.53 divided by 1.125. I make that £17.36. Okay. These sorts of questions, just think is my answer sensible here at this point. Yeah, it was increased, so the price we're looking for is meant to be less, so I think that does look reasonable. £17.36. Question 5. Jess saves 2p, 5p and 10p coins. She has 45 10p coins. She has 8 times as many 2p coins as she has 10p coins. And she has £17.70 in total. Find out the total value of the 2p coins to the total value of the 5p coins written as a ratio and given it in its simplest form. Okay. Right, so let's just work this through then. So she's got 45 10p coins. So 45 times 10p coins. And we have 8 times as many 2p coins as 10p coins. So in other words, she's got 45 times 8 2p coins. And isn't she? What's 45 times 8? Well, that's double, double, and doubling again. So 45 doubled is 90, double it is 180, double it is 360. So 45 times 8 is 360. She's got 360 2p coins. So what she's got, 45 10p coins, and she's got 360 2p coins. How much is that altogether then? So that is equal to 450 plus 720, which comes to 770, 1,170, or £11.70 worth of change so far. Okay, so that's the amount of 2p's and 10p's she's got. So that's the value of 2 and 10p's is this. So the value of the 5p coins is going to be the total cost less what the other 2 coins were worth, isn't it? So if I take, I think I'm just going to stick with pence for now, 1770 minus 1170. So that leaves me with 600 then, doesn't it? Or £6 worth of 5p's. Okay, so then what I want to know then is the number of 5p coins. How do I need to know the number? No, I need the values. So I've got, so that's the value then of my 5p coins, and the value of the 2p coins we said was 360 times 2, that's 720. So then the ratio of the value of the 2p coins to the value of the 5p coins is going to be 720 to 600. Now to cancel that down, I'm just going to use the fraction key on the calculator because ratios cancel down pretty much the same way. So if instead I write 720 over 600 using the fraction key and press equals, it's going to cancel down that fraction for me. That's given me 6 over 5. And so they're the same values I can use in my ratio then, can't I? So this isn't a fraction, but it cancels down the same way, so that's going to cancel down to 6 to 5 as well. Okay, so that's my answer, 6/5. Question 6a, part of the regular polygon is shown. Assume that the polygon is an octagon. Work out the size of the exterior angle. Okay, so if it's an octagon, then it has 8 sides, and as it has 8 exterior angles, and the exterior angles all add up to 360 degrees, then we can say that one exterior angle is equal to 360 divided by the number of sides, 8. And 8 goes into 360, 45. So that's 45 degrees. Part B says, in fact, the polygon has more sides than an octagon. What does this mean about the size of the exterior angle? Okay, so we did have the size of the angle was equal to 360 divided by 8. But if it isn't 8, if it's bigger, then the denominator of my fraction is getting bigger. What does that mean in terms of the overall size of the number? If you get a bigger denominator, then overall your fraction is smaller, isn't it? Because a quarter is smaller than a half. Okay, so the bigger the number part of the denominator is, the smaller the fraction is. So that means the overall size is going to go down. Okay, so tick one box. What do we know about the size of the exterior angle? It is more than the answer to part A. No, it's the same as the answer to part A. No, it's less than the answer to part A, isn't it? So it's that one. Okay, it's definitely less. Question 7. In a game, an ordinary fair 6-sided dice is rolled. The fair spinner is shown is spun. The score is the dice number substituted into the spinner expression. What a fun game. Complete the table to show all of the possible scores. Okay. So, if it lands on 1 and 2x, then 2 lots of 1 is going to be 2. If it lands on 2x and 2, then 2 lots of 2 is 4. 2 lots of 3 is 6, 8, 10, and 12. If it lands on 3x and 1, so 3 lots of 1 is 3, 6, 3 lots of 3 is 9, 3 lots of 4 is 12, 3 lots of 5 is 15, 3 lots of 6 is 18. And then if it lands on x squared and 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25, 6 squared is 36. Part B says the player wins the game if their score is 10 or more. Work out the probability that they win the game. Okay, so probability of win is successful outcomes, scores more than 10, divided by total outcomes. How many outcomes there are altogether? Well, in this grid, it's a 3 times 6 grid, and 3 times 6 is 18. So there are 18 outcomes altogether. Now, how many of those outcomes are 10 or more? Well, that's 10, and that's more than 10. That's more than 10, that's more than 10, that's more than 10. That's more than 10, that's more than 10, that's more than 10. So I make that 2, 4, 6, 8 outcomes that are more than 10. So the probability then is going to be 8 out of 18. Part C says the game is played 711 times. Estimate the number of games that are won. Right, so expected number of successes is going to be the probability times the number of trials. Okay, so in this case, it's going to be 8 over 18 times 711, whatever that is. So 8 over 18 times by 711, it comes out to 316. So I would expect there to be 316 wins. I'd like to get exactly that, but it's going to be there or thereabouts. Question 8, a minus 3 multiplied by x squared plus 2b is identical to 5x squared plus 12. Work out the values of a and b. Now, take note, this is an identity problem. This is an identity symbol in here. So don't be moving things over the identity. That's not how you do these. Okay? What you have to do is make one side look like the other and then read off the values that go with each. Now, actually, these all pretty much look like each other already. So I've got a term in x squared, and comparing the coefficients of x squared, I can see that this bit here, look, matches with this bit over here. So I've got, on the left hand side I've got a minus 3x squared. On the right I've got 5x squared. Now if these two things are identical, every part of them must be identical. Okay, so the coefficients of x squared must be, so comparing coefficients of x squared, that gives us a minus 3 is equal to 5. Okay, so rearranging for a, that's pretty simple, isn't it? Then that's a is equal to 8, so that's a. And then the other thing we can do is we can compare the constants on the end. Look, I've got on the left hand side I've got 2b, and on the right I've got 12. Okay, so let's compare those next. So comparing constants, then I'm going to get 2b is equal to 12, and therefore b is going to be equal to 6. Question 9. ABCD is a parallelogram. AD and BC are horizontal and have length 5 centimeters. The diagonal of ABCD cross at E. Work out the two possible pairs of coordinates of E. So I've got A, B. So the other ones I don't see are C and D. But I know that AD is horizontal and worth 5 squares. And BC is horizontal and worth about 5 squares. So either it's going to be 5 squares to the right of A and B. So that would put D, 5 squares to the right would be here. So D could be here. So I'm going to call that D1. Or C could be 5 units to the right of B. 1, 2, 3, 4, 5 could be here. Okay, so I'm going to call that C1. So joining them up quickly to show my first possible parallelogram, just for clarity. Okay. Alternatively, I could have my 2 points D and C to the left of my points A and B. So if I count instead to the left, 1, 2, 3, 4, 5 there, I could have a point here. So D2 could be here, and 1, 2, 3, 4, 5. C2, the other point, could be over there, couldn't it? So again, then I'm going to have a second possible parallelogram on this side. Okay, so just finishing that one off. And there's finally, it says work out the two possible pairs of coordinates E where the diagonals of the parallelogram cross. Okay, so putting in the crosses in the middle. So in my diagonals of parallelograms do bisect each other, but they don't cross at 90 degrees necessarily, unless it's a rhombus. Okay, so yeah, so you can see the points then, isn't it? So I've got a possible point here, I'm going to call E1, and then this one over here, which I'm going to call E2. So then the coordinates of E1 then, oh, what's that? That's 4, 6. And E2, that is minus 1, 6. Okay. Question 10. Write down the translation vector that maps shape A onto shape B. Now, when you're drawing translation vectors, make sure you are joining like points with like points. I often see students, drawing a line between the two closest points on the shape, like that one there. But you'll notice I'm joining. If I do that, I'm joining the top right corner of A to the top left corner of B, so that's not correct. Okay, so it has to be like corners with like corners. So pick a shape on one object, pick the matching point on the other, and then look at your vector that lies between those 2 points. We're going from A to B, so my line is going this way. Okay, so what is that vector there then? Well, it is so many units to the right and so many units up. So that's going to be what, 1, 2, 3, 4 units to the right and 1, 2, minus 3 units up. So that's going to give me the vector 4, minus 3 there. 4, minus 3. Now vectors are not fractions, so don't put a line in between them like that. And they're not coordinates. I've got one number on the top and another number underneath. Okay, do it like that, you'll get the marks. Question 11, you're given the formula for the volume of a sphere. It's 4/3 pi r cubed. A bowl is a hemisphere with radius 12 centimeters. Water is poured into the bowl at a rate of 325 cubic centimeters per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show your working. Okay. So note, first of all, we've got the volume of a sphere equation and we want a hemisphere. So we're going to have to adapt this, aren't we, to make it into the volume of a hemisphere. So the volume of a hemisphere is going to be half of the volume of a sphere, isn't it? So it's half of 4/3 pi r cubed. Okay, so probably you can just divide that 2 into the 4 and make it 2/3 of pi r cubed then, isn't it? Okay, that's what you want. And then what is r? R we're given as 12, so that's 2/3 of pi times 12 cubed. Okay, now I'm going to type this into the calculator, but I'm just going to leave it in terms of pi now, just to make it easier to write down. So I'm going to do 12 to the power of 3, and then times 2 divided by 3, and that comes to 1,152. So that is 1,152 lots of pi. Okay, I'll evaluate it at the end. I don't really need it now. So water is poured into the bowl at a rate of 325 cubic centimeters per second for 8 seconds. So how much water goes in then? So volume of water that goes in, that is just going to be the number of seconds that water was going in multiplied by the amount that's going in every second, isn't it? So that's 325 times 8. So 325 times 8, that gives me 2,600. Okay, cubic centimeters. So does the water fill more than 70% of the bowl? Is 2,600 70% of 1,152 lots of pi? Okay, well, let's find out. So percentage would be, so percentage filled would be the amount of water going in divided by the amount of water that it could hold times by 100 to make it into a percentage then, isn't it? Okay, so what's that then? So 2,600 divided by 1,152 lots of pi times 100. I make that 71.8 and change. So just rounding that off, I'm going to make that 71.8%. So does the water fill more than 70% of the bowl? Yes, it does. Yes. More than 70% is filled. Okay. Question 12. Show that these two rectangles are similar. Now, if two rectangles are similar, then all their sides are going to be in the same ratio. So what is that ratio then? So if I take these two and form a ratio, I'm going to get 5/12. Okay. And then if I take the other one, I'm going to get 8/19.2. Is that the same thing as 5/12? I don't know. Well, let's just type it into the calculator. 8 divided by 19.2. Oh, yeah, look, it's 5/12. So that is equal to 5/12. So we can say the sides are in the same ratio. When that was 5/12. And so the rectangles are similar. Okay, so the sides are in the same ratio and so the rectangles are similar. Okay, so often with these questions we're finding like you know, like the scale factor here, but this time we're doing something different. We're just showing that the sides, when you divide one by the other, you get the same number, and therefore they must be in the same ratio, and therefore they are similar. Question 13. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x/3 tea bags per minute. Okay, so If a factory packs X boxes of tea bags per hour and each box contains 80 tea bags, then tea bags per hour is going to be the number of tea bags in each box times by the number of boxes, which is 80x. Okay, so if I want to then do tea bags per minute, then I'm going to have to do 80x divided by 60 because there are 60 minutes in an hour. So 80 divided by 60, that comes to, well, it comes to 4/3. So that is the same thing as 4x over 3. Question 14. A company has 123 employees. Information about their hourly rates is shown in the table. Okay, so most of them look at earning between 20 and 14 pounds, but some of them are earning more. The owner of the company uses the data to make two statements. Statement A, over 30% of the employees have an hourly rate that is more than £17. The average hourly rate of pay is more than £20. State working that supports statement A. Over 30% of employees have an hourly rate that is more than £17. Well, now, these guys here are definitely earning more than £17. These guys here are definitely earning more than £17. Now, £17 lies kind of in the middle of this group here, doesn't it? It's kind of halfway between 14 and 20. Okay, so what we're going to do with this 32, well, we could assume that all of them are earning more than £17. We could assume that all of them are earning less than £32, but I think it's fairly okay to assume that half of them are going to be more than 17 and half of them are going to be less than 17. Okay, so 17 lies halfway between 14 to 20. So if it lies halfway, then let's use half of 32. So 32 divided by 2, that's equal to 16. So estimate that 16 employees earn between 17 and 20 pounds. Okay, so if there are 16 who earn between 17, so then the total earning £17 plus is going to be equal to those 16 that we just worked out plus the 15 plus the 10 then, isn't it? So that comes to 16 and 15 is 31 plus 10 is 41. 41 employees. Okay, and then we want to show that that is over 30% of the company. Remember, there are 123 employees altogether. So then percentage is going to be my 41 employees over the 123 employees times 100. Okay, so that came from there. Look, that came from there. So 41 over 123 times 100. So 41 divided by 123 times by 100, and that comes to 33.3 reoccurring, so that's about 33.3%. Okay, so I can say then statement A is justified. Part B says, why might statement A not be true? Well, it might not be true. We assume that half of that group of 32 earned between 17 and 20 pounds, but they all might earn 15 pounds for all I know. So we could say that all of the 32 employees in the 14 to 20 group might earn less than £17. Okay, so all of that, all of the 32 employees in the 14 to 7 group might be on less than £17, and therefore it wouldn't be enough of a percentage, would it? And so 25 over 123 would be equal to, that would be equal to like 20.3%. So it could be as low as 20.3%. Part C says work out an estimate of the mean to support statement B. Well, estimated mean, you want to take the midpoint of each boundary. So in this case, that would be halfway between 10 and 14. That would be 12. Halfway between 14 and 20. We all knew that was 17. Halfway between 20 and 40 is 30. And halfway between 40 and 100, what's that, 70? Okay, and if we multiply through then, so 12 times 66 is 792. 17 times 32 is 544. 30 times 15 comes to 450. And what 70 times 10, I can probably do in my head, is 700. So adding those up then, so 450 plus 700 plus 544 plus 792, I make that 2,486. Okay, so that adds up to 2,486. Okay, so my estimated mean is the sum of the frequencies times the x values divided by the sum of the frequencies, which is, so this number here, look, is that one, 2486, and the sum of the frequencies, that's that one there, look, it's going to be 123. So that's 2486 divided by 123. What's that come out to be? 2486 divided by 123. That is roughly 20.2. 20.2. Okay, so what we're trying to prove, the average hourly pay is more than £20. So we can say yes, this exceeds £20. Okay, so statement B is justified. Right, so part B says, or part D says, why is the mean not the best average to represent the data? Okay, well in this case, the average, the mean average is overly influenced by these few people earning the big bucks at the end. You can see most of the employees are earning, you can see the vast majority, 66 and 32, what's that, 98 out of the 123 employees are earning less than £20. Okay, but the mean is pulled up by this much smaller group of 10 managers at the top earning between 40 and £100 an hour. Okay, so yeah, those people are dragging up the mean to the higher value. So it would be better to use a type of average that is not affected by those, those few at the top. So a good one to go for might be median, the median salary, because that is unaffected by your outliers at the one end of the data or the other. So I'm going to say mean is affected by the very few high earning employees which drags the mean value upwards. Better to use the median value. Okay, so yeah, you're better off using the median value because that's doesn't affect it. It's not affected by the larger values at the end. Question 15, expand x squared minus 9xy times 2x plus 5y. Okay, so a little bit more complicated than normal, but it's just a standard multiplying out double pair of brackets, isn't it? So you can either do this as first outside, inside last, or two eyebrows, a nose, and a mouth, or you can use the grid method. I'm going to quickly do this in the grid method, I think, because I think it's a good way of doing it in an exam where you're not going to get flustered and lose a term. Okay, so it's a little bit, I don't know, some of my higher tier students get a bit sniffy when I tell them this, but actually, you know, in an exam scenario, it's easy to lose a term when you're under pressure. So, but doing the grid method, you very much see all of the four terms and then can deal with collating them together a little bit easier. So 2x times x squared is 2x cubed. 2x times minus 9xy, that's going to give me negative 18x squared y. 5y times x squared, that's going to give me 5x squared y. And 5y times minus 9xy, that's going to give me negative 45xy squared. Okay, so notice I've got one term in x cubed, I've got two terms in x squared y, and I've got one term in xy squared. Okay, so just writing that down as my final answer then. My first term is 2x cubed, that's the yellow one. And then I've got those two terms that I'm going to combine. 5x squared y minus 18x squared y. Well, 5 minus 18 is minus 13. So that's going to be minus 13x squared y. So that's from the two green terms. And then finally, I've got minus 45xy squared. So minus 45xy squared. Okay, and that's the blue one. Okay, that's my final answer. 2x cubed minus 13x squared y minus 45xy squared. Question 16. Line A has equation y equals ax minus 1, passes through the point 7, 13. Line B has equation 5y minus 3x equals 4. Show that line A has a greater gradient than the line B. Okay. So I've got a partial equation here, y equals ax minus 1, and I know a point it passes through, so that should be enough information for me to find A. It's a bit unusual. Normally at this point we know M and we're finding C with the point, but yeah, works the other way around too. If I know C and I want to find M. So we know that for line A, so line A passes through 7, 13. So subbing those into the equation, so 13 is equal to A lots of 7 minus 1, then, isn't it? Subbing the 13 and the 7 in. So that tells me that 7a is equal to 14. So adding 1 to both sides, I'm going to get 7a is 14, and therefore a is equal to 2. So the gradient then of line A is equal to 2. Gradient M1 is equal to 2. Okay, so that's my gradient. And then for line B, what's the gradient of B then? So I'm going to rearrange it so it's in the form y equals mx plus c. So at the moment I've got 5y minus 3x equals 4. So adding 3x to both sides, I'm going to get 5y is equal to 3x plus 4. Right, and then dividing both sides by 5, y is going to be 3x plus 4 over 5. which is the same thing as y is equal to 3x over 5, or 3/5 of x, plus 4/5. Just dividing both terms by 5. Okay, so therefore the gradient of this line of b is going to be, well, it's just going to be that value there then, isn't it? 3/5. Okay, so we know that m1, the gradient of line A is 2, and the gradient of m2 is 3/5. So we know now then that m1 is bigger than m2. Question 17, we have got a triangle ABD, which has been divided into, it's a non-right angle triangle, isn't it? But it's been divided into two right angle triangles by dropping a line from A down to C, which is perpendicular to the baseline. And we need to work out angle X. Now, when you've got right angle triangles, you can use SOHCAHTOA, can't you, for basic trigonometry to work out a value, but you need to know two things in a triangle to work out any one thing. And at the moment, this value X is in a triangle ABC, but we only know one thing. We know the hypotenuse of that triangle. Okay, so that's not enough. So in order to work out X, we first need to cast our attention over to this other triangle here, where we do know two things. We know the angle up here, angle A, where we've got 36, and we've got that side there, the hypotenuse, which is worth 4. Okay, so what we're going to do first is if we're going to find this communal length here, AC, okay, which is the adjacent of this particular triangle, the green triangle. This one is the hypotenuse. This is the opposite, which you don't really care about, don't want. So writing down SOHCAHTOA. So in triangle ACD, then what we're going to use then, we don't want the opposite, so it's not any of the trig ratios with an O in it. It's the cosine, isn't it? That's the one we want. So in triangle ACD, then the cosine of theta is equal to the adjacent over the hypotenuse, just stating the cosine formula. And then, so in this particular triangle, cos theta, the angle is 37. The adjacent is what we're trying to find. Let's just call it, well, let's just call it what it is. Let's call it AC over the hypotenuse, which is 4. So rearranging, then my side AC is going to be 4 lots of cos 37, which I'm going to write down as a rounded off version, but I'm just going to keep the full calculator display for my next calculation. So that comes to 3.19 and change. I'm just going to write down 3 digits, but like I say, I'm going to use the one that's in my calculator for the next step. Right, now I know what AC is, I can move on to the second triangle, which is triangle ABC, where I know, again, I now know the opposite, isn't it? So in this triangle, this one is the opposite, and I've got the hypotenuse, and down here I've got the adjacent. And now this time it's the adjacent that I'm not interested in. So again, writing down SOHCAHTOA for a second time, SOHCAHTOA. Now in triangle ABC, it's actually the A that we're not so interested in. So getting rid of the trigonometric ratio has got A in it. That leaves me with this one, the SOH. Okay, so I'm going to write down sine theta is equal to the opposite over the hypotenuse. Okay, which is, the opposite is my side AC, isn't it, that I found earlier. So that is 3.19, and that is going to be divided by H, which is 9.3, and actually, like I said, this is X this time, isn't it? So it's sine X equals that. So typing that into my calculator, I've already got the 3.19 long version in my calculator. I'm going to keep that. I'm going to divide it by 9.3, and then that gives me 0.343, and then I'm going to find the inverse sine of that, isn't it? The inverse sine of that. So shift sine answer, that's given me a value of X of 20.1. Okay, and that's my answer. 21.1 degrees. Question 18, rearrange y equals x plus 8 over x to make x the subject. Now, notice I'm making x the subject. I've got more than one x. That's a slight problem, isn't it? Okay, so when we've got situations like this, the first thing we need to do is kind of collect all those x's together. Okay, now I'm going to do that by multiplying first both sides by x, just to remove that denominator on the right. So times in both sides by x, I'm going to get x, y equals x plus 8, haven't I? Because the x is going to disappear on the right and arrive on the left. Okay. Next thing is going to collect all the x's on one side. So if I take x away from both sides, I'm going to get xy minus x is equal to 8. Okay. Now notice I've got an x here now and an x here. So both these terms have got an x in it, which means I can factorize that x out of both terms. So x times y minus 1 is going to give me xy minus x. Okay, now I've only got the 1x, so happy days. So now all I need to do is divide both sides by y minus 1, and that's going to give me x is equal to 8 over y minus 1. Okay, so x is the subject. I've just got the 1x. Everything else is on the other side. I'm done. Question 19. Here are the first four terms of a quadratic sequence. 3, 20, 47, and 84. Work out an expression for the nth term of the sequence. Now, when you're finding the nth term of a quadratic sequence, you've got two basic approaches that students use. The first approach is finding the second common difference, halving it, form a partial sequence from that, take it away from the original sequence, and then find the linear component of what's left over. Okay, that's one way. The other way, which I'm going to go through this time, is to use the general form of a quadratic equation and try and piece it together from that. Okay, and using simultaneous equations, which is what I'm going to do here. So the general form of a quadratic equation is ax squared plus bx plus c. Okay, so what we need to do is find out what those values of ax squared plus bx plus c are. Okay, well we generally write that, but you know, because it's a sequence, we tend to use n's rather than x's, but other than that, it's the same thing. So what I want to do is find the values of a, b, and c here. Okay, so now when we've got u1, the first term, n is 1, isn't it? So that would give me a lots of 1 squared, which would be a, plus b lots of 1, which would be b, plus c, and that is equal to 3. Okay, my second term, u2, that's going to be a lots of 2 squared, 4a, plus b lots of 2, 2b, plus c. And that is equal to 20. Okay, I'm getting these numbers from the sequence. Okay, so that's the first term, that's the second term. Okay, and these things here in between, I'm getting by just subbing the value of n into this thing here and working out what's left. Okay, and then the third term, because we need 3 if we want to find 3 unknowns, that is going to be what? So for the third term, an squared, a times 3 squared is 9a, plus b times 3, 3b, plus c, and that's equal to this term over here, it's the 47. Okay, so what I've got now is I've got 3 equations in 3 unknowns, a, b, and c, which I can hopefully then go on to use simultaneous equations to solve. So 2 equations and 2 unknowns, you eliminate one of the variables and then you've got the other one, haven't you? But with 3, you've got one extra step here, or a couple of extra steps, because you have to eliminate 2 variables. So I'm going to do this first by subtracting the u1 expression from u2. So I'm going to do u2 minus u1, and that's going to give me the second equation minus the first one. So 4a take away a is 3a, 2b take away b is b, c take away c cancels, they eliminate, and 20 take away 3 is 17. Okay, and then taking also, if I'm finding u3 minus u2, the third equation minus the second equation, that's going to give me 9a take away 4a is 5a, 3b take away 2b is b, and c take away c is 0. and then 47 take away 20 is 27. Okay, so now you can see I've got two more equations. I've got 3a plus b is 17, 5a plus b is 27. So these two equations and two unknowns, you can see I've got a b on the end of each. So if I then take those away from each other, so call in this one, this is like my fourth equation, and that's my fifth equation. So then taking the fourth one away from the fifth, so equation 5 take away equation 4. So 5a take away 3a is 2a, and b take away b is zip, and 27 take away 17 is 10. Okay, so then 2a is 10, so a must be equal to 5. Okay, so I now know the first term of my expression. Because I know a is 5, I know I've got 5n squared. So I just need to find b and c now. Okay, so now I know a, I can sub that back into one of my original my middle equations, which has got a and b in it. So substitute a equals 5 into either equation 4 or 5. I'm going to go with equation 4. So substituting a is 5 into equation 4, then 3 lots of a, which is 3 lots of 5, plus b is equal to 17. Well, 3 lots of 5 is 15, so 15 plus b is 17. That means b is 2. Okay, so now I've got 5n squared plus 2n. Now I just need the c part to finish it off, don't I? And then so now I know a and b. I know a is 5 and b is 2. So sub in that back into u1. So substitute a equals 5, b equals 2 into u1. The first thing we started with, I had a plus b plus c is 3. So a is 5 plus b is 2 plus c is equal to 3. So 5 plus 2 plus c is 3. 5 plus 2 is 7. Take 7 away from both sides. C must be equal to minus 4. So now I know it's that. 5n squared plus 2n minus 4. Therefore, nth term is 5n squared plus 2n minus 4. Okay. Now, why do I like this way better? This might look super complicated at the beginning, but every time you do this, all of this bit here is the same. The only thing that changes is those 3 numbers at the end. That's the first step, writing those down. The second step, all of this bit is the same. The only thing that changes is these numbers at the end. So after you've done it a couple of times, it's actually really quite straightforward to do it this way. Okay, and then it makes more sense to me. I know it makes sense. I know simultaneous equations makes more sense to me than taking the half of the middle second difference of this thing. I don't really get why it is that. This makes logical sense to me, so I'm better at remembering it. Okay, but you do you. The other way also works. As long as you get the right answer at the end of the day, that is the way, isn't it? All right. Question 20a. P, Q, and R are points on a circle. S is the point in the side triangle PQR. Assume that S is the center of the circle. Work out the size of angle X. Right, well, if S is the center of the circle, then using the angle at the center, 130 is twice the angle at the circumference, then we would know that X is going to be half of 130 then, isn't it? So X equals 130 divided by 2. What's 130 divided by 2? That is 65 degrees. Okay. Part B says, in fact, the center of the circle is on PS, but not on S. Okay, so that means the center of the circle lies actually kind of somewhere along this line here. Okay. What does this mean about the size of angle X? Does it mean that it's the same? Does it mean that it's greater? Does it mean that it's smaller? Does it mean that it's impossible to tell? Okay, well, what happens then to P center R? Does that angle get bigger or smaller if the center moves along S towards P? Okay, so let's just add another line in. Let's see what we think. So if we add another line here, Okay, then is this angle here between our new center and there, is that angle bigger or smaller than 130? Now I would argue that it's bigger. Now the reason for that is that this angle is staying the same because P and R are not moving, okay? O is moving along SP, okay, but the angle between P and S and the P and O is going to be the same, isn't it? So this angle stays the same, but this angle over here, look, can you see it's getting smaller? So that angle down there at R is getting smaller, and therefore the angle up at O is definitely getting bigger. So if that angle is bigger than 130, then that means that X must also be bigger than it was before, because it's still half of that bigger angle in the center. So I think it is going to be greater than the answer to part A. 20C, for a different circle, AB is a tangent at A, C and D are on the circumference of the circle, and AC equals CD. All that information is already on the diagram. Here is Simon's method to work out the size of angle Y. Angle ADC is 70 degrees, alternate segment theorem. Therefore, Y is 70 angles in an isosceles triangle. Okay, so what he's saying is that this angle here must be equal to this angle here then, because of the alternate segment theorem, and therefore because look, you've got an isosceles triangle, then that must be the same as well. But he is wrong. Why is he wrong? Because in the alternate segment theorem, it's actually this angle matches with this one up here at the top of the isosceles triangle. Okay, so the reason is the alternate segment theorem actually says angle BAD is equal to angle DCA or ACD, and not angle ADC. So if that's 70, so what would Y then be? So if that one up there is 70, then you've got 110 degrees to share out between those two at the bottom of my isosceles triangle. So that would make Y equal 55 and not 70 then, wouldn't it? Okay. But yeah, so she's just, or Simon's just picked the wrong angle. It needs to be subtended from the same chord. So tangent, line drawn at the point of contact, then it's got to be subtended off of that chord. That's what the alternate segment theorem states, not that one down there. Question 21. Magana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest that she needs. Okay, so final original multiplier using our triangle. Don't know why it's pink. Let's switch pen. Final original multiplier. So what do we need here then? So what we want then is the multiplier, because we don't know what the percentage is that we need. We want to have at least £500. So let's go for 560 for now, and the original is 500 as the amount that she started with. Okay, so then normally the compound interest formula goes final equals original times multiplier raised to the number of years. Okay, and our years here then are going to be 3. There are 3 of them. So that would be final price of 560 is equal to the original price of 500 times my multiplier to the power of 3 then, isn't it? Okay, so then my multiplier, we're just rearranging that. So then dividing both sides by 500, I'm going to get 560 over 500 is equal to multiplier cubed, and then taking the cube root of both sides then, so my multiplier is going to be 560 over 500 all cube rooted. Okay, so what's that then? 560 divided by 500, cube root of that. So shift cube root of 560 over 500. I make that 1.0384. Now I'm going to write that out correct to 4 significant figures for now. So my m value is equal to 1.038. Now this is more decimal points I'd normally write down, but I'm going for 1.0384 here. I'll explain why in a minute. So the multiplier then is that. So that as a percentage is going to be 103.84%. Okay, making the annual interest equal to 3.84%. Now normally I would round that down and I would say that, you know, 3.84 is closer to 3.8, but if you actually use a multiplier of 3.8, it's actually going to come out slightly too low. So I'm actually going to round this up and I'm going to put it down as 3.9%. Okay, because otherwise you would get slightly less than £560, because if I rounded down the interest rate, I worked it out exactly 560. So if I round down, it's going to be less than 560, and actually I want it greater than 560. Question 22. An approximate value of a root of an equation x can be found using the iterative formula x to the n plus 1 equals the cube root of 5 lots of x to the n squared minus 2 lots of x to the n minus 3. The starting value is x1 equals 4. Work out the values of x2 and x3. Okay. Now, what I'm going to do is I'm going to use, because I need to do this several times, I'm going to type 4, the value of x1, into the calculator and press equals, and then I'm going to use that with my answer key to type it into the next value for x2, if you see what I mean. So I've got 4 stored as the last answer, so then typing in the new equation for x2, I'm going to use the cube root key, cube root of 5 lots of, and then I'm going to do answer squared, 5 times answer squared. Might put that in brackets, I don't know if it makes any difference. So 5 times answer squared, and then minus 2 times the answer minus 3. Okay, so then if I press equals, it will feed 4 in where I've written the answer and work out the new value. Now that comes to 4.1015. I'm going to round it off to 4 significant figures. I'm going to write down 4.102. Okay, right, so and because of the way I set it up, now that 4.101 and change is now my answer, if I just press the equal sign again, it's going to feed that answer back into my iterative function and give me the value of x3. So just pressing equals, that tells me that x3 is 4.1776, which I'm going to round up to 4.178. 4.178. Right, and so then by continuing the iteration, show that the value x is more than 4.25. So I'm just going to have to keep doing it a few more times then. So going to do x4 then, just press equals again. That gives me 4.234. 4.234. Press it again. I'm going to get, well, that's already there then, isn't it? x5, that's equal to 4.276, rounded off to 3 significant figures, which exceeds 4.25 as required. Okay, so yeah, just a bit of a calculator trick there to keep feeding your answer back in on itself, makes those sort of questions a whole lot easier. Question 23, here are 3 sets of cards. I've got set A, which has got numbers 1, 1, 3, 5, 5, 5, 6 and 8. Set B, slightly fewer cards. Set C, even fewer cards. Now in a game, a player has 2 options. Option 1, pick 2 cards from set A, or option 2, pick 1 card from set B and 1 card from set C. The cards are picked at random. The player wins if the total of their 2 cards is exactly 10. Which option gives the better chance of winning? Okay. I think probably the easiest way to do this is a bit like a sample space for these numbers, and then I can work out which ones are going to give me exactly 10 then. So if I did a sample space for set A, picking 2 from set A, I'm going to have 1, 1, 3, 5, 5, 5, 6, 8 in one direction. And down the other way, I'm going to have 1, 1, 3, 5, 5, 5, 6, 8 in that direction. So altogether, that's going to give me, that would give me what, 1, 2, 3, 4, 5, 6, 7, 8 outcomes. 8 times 8, which is 64 outcomes altogether, isn't there? Okay, so that gives me 64 outcomes. Now, which one of those outcomes is going to give me 10? Well, the only ones that are going to give me 10 are where I'm going to be adding the 5s together, isn't it? So I'm going to get like a 10 here. Adding 5 and 5 is 10, 10, 10, 10, 10, 10, 10, 10, 10. Now, all the other numbers are not 10. Okay, all those other numbers here, 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 and here, these are not going to give you 10, are they? Okay, so you've got nine successful outcomes. Okay, out of a total of 64 outcomes. So from set A, then the probability of getting a 10 is 9 successful outcomes out of a total of 64. But while I've been doing that, I realized I've overcounted with the other one because actually you can't pick the same card twice, so you actually can't get any of these numbers down the lead diagonal, can you? So that includes that one, that one, that one, that one, and that one. So we don't have 64 outcomes because you can't get that one along the lead diagonal. It's actually minus 8 there, which is actually 56 outcomes and not 64 as I first said. So I'm going to change that to 56. And it doesn't have 9 successful outcomes because I can't have those 3 in the middle. So it's actually 6 successful outcomes there. Sorry, my mistake. I just kind of thought about that after I was halfway through the problem. So that's going to be 6 out of 56 there. Okay. Now, in set B and C, if I pick one from each of those, so if I do a similar kind of analysis, so got my numbers 1, 2, 4, 6, 8, 8, 9 in that direction, and 3, 4, 5, 6 in that direction, then which ones are going to give me 10? Are any of them going to give me 10? Well, the 4 and the 6 is going to give me 10 there. So I'll have a 10 there with the 4 and the 6. And the 4 and 6 in the other direction is going to give me a 10. Are there any more 10s? 3, no. 4, got that, just that one. 5, there's no 5 to match it with. 6. So there are only 2 options, isn't there? So altogether, there are 1, 2, 3, 4, 5, 6. 2, 4, 6, 7. 7 times 4 equals 28 outcomes altogether. Okay, of which there are 2 successful outcomes, aren't there? Just the 2 there. 2 successful outcomes. Okay, so that would give me for set B. So from set B and C, isn't it? From set B and C, then the probability of getting a 10 is equal to those 2 successful outcomes out of a total of 28 outcomes. So, right, so I've got 6 out of 56 and 2 out of 28. Now I notice that 28 is half of 56, so that is the same as 4 out of 56 then. So clearly you're going to be slightly more lucky if you choose from set A rather than set B. So that's option 1. Question 24. A is 65 to the nearest integer. B is 30 to one significant figure. Work out the upper bound of 2a squared minus b squared. You must show your working. Okay. Right, so imagine a number line. If I've got 65, which this number has been rounded to the nearest whole number, one whole number below would be 64, and one whole number above would be 66, wouldn't it? So the numbers that round to 65 are going to be the ones that are halfway between those or closer. Okay, so halfway between 64 and 65, that's going to be 64.5. That's going to be my lower bound, and my upper bound is going to be halfway between those. They're going to be 65.5. Okay, so that's for A. And then B, again, if I start with a number line, now this one is 30 to one significant figure. Now one significant figure is the first digit of my number, which is the 3, and that's in the tens column. So if it's been rounded to the nearest 10, 10 units below would be 20, 10 units above would be 40. And so the numbers rounding to 30 are going to be halfway between those or closer. So halfway between 20 and 30 is 25, and halfway between 30 and 40 is 35. Okay, so they're my bounds for B. So A lies between 64.5 and 65.5, and B lies between 25 and 35. Now we want to work out the upper bound of 2a squared minus b squared. Upper bound of 2a squared minus b squared. So I want to get the biggest number that I can get. Now the biggest number I'm going to get is if I pick the biggest number for A. So that one needs to be my biggest one. But then I'm going to take away something. Now if I pick biggest B, then I'm taking away the biggest thing possible from my total, and I'm going to end up with a smaller number. So for B, I want to pick the smaller one of the two. So for B, I'm going to be picking 25. Okay, so my upper bound I'm going to get from doing two lots of 65.5 squared minus my lower bound for B squared. Okay, so then tapping that into the calculator, then 2 times 65.5 squared minus 25 squared. That comes out to be 7955.5. So it's 7955.5, and that's my answer. 7955.5. Question 25. Show that x minus 5 over x minus 2 plus x plus 5 over x plus 2 simplifies down to ax squared minus b over x squared minus 4, where a and b are integers. Okay, so I need to kind of take these two algebraic fractions and let 2 become 1. Okay, so I need to find a common denominator of these two. So if you've got two fractions, and you want to add them, you need a common denominator. So what's common out of x minus 2 and x plus 2? Well, you can normally find a common denominator if you multiply the two things together, won't you? So that is equal to x minus 2, x plus 2 as a kind of a single denominator on the bottom, like that. On the top, I need to work out how many times x minus 5 goes into x minus 2, x plus 2. It goes in x plus 2 times. So on the top, I'm going to get x minus 5, x plus 2. Okay, so notice I've got these two things here and here, on the bottom here and here. And then this number up here, x minus 5, gets multiplied by the x plus 2. Okay, the thing on the right hand side. Okay, and then plus on the other side, I'm going to get x plus 5 over x minus 2, the yellow one. So that's going to give me x plus 5 times x minus 2, because x plus 2 goes into x minus 2, x plus 2, x minus 2 times. Okay, so it's the yellow bracket multiplied by the purple one. Now, if you ever get stuck with this, you can just kind of do what you would do with fractions. If I had 2/3 plus 3/4, you would find a common denominator by multiplying the 3 and 4 together, give you 12, and then you would say, well, 3 goes into 12 4 times, so you get 2 times 4 plus 3 times 3 on your value. It comes out the same, doesn't it? Okay, so if you're ever stuck and not quite sure what to do, you know, just do it with numbers and do the same thing with your algebraic fractions. It's just generalized arithmetic, follows all the same rules. Okay, so let's multiply out some of these brackets. So x minus 5 times x plus 2, going to use FOIL on those brackets there then. First, outside, inside, last. So x times x is x squared. Minus 5 times x is minus 5x. X times 2 is 2x. Minus 5 times 2 is minus 10. In the second bracket, I'm going to get x squared. Then x times minus 2 is minus 2x. 5 times x is plus 5x. 5 times minus 2 is minus 10. That's on the top. On the bottom, I've got x minus 2x plus 2. That's just the difference of two squares, isn't it? So multiplying those out, I'm going to get x squared minus 4 on the bottom. You could multiply out your 4 terms and you'll see your two middle ones disappear. I just recognize that as difference of two squares, so I'm just going to go there in one jump. Right, so now on the top, you're going to have things that cancel and things that don't cancel here. So I've got a minus 5x, and that cancels with that 5x. I've got a 2x there, and it cancels with the minus 2x. What doesn't cancel are my x squared terms here and here, which are going to add together. And my minus 10 and my minus 10, they don't cancel, so I'm going to have to combine those together as well. Okay, so that's going to give me x squared plus x squared is 2x squared. Minus 10 is minus 20, and that is over x squared minus 4. Okay, so you can see it is of the right form. I've got x squared minus 4 as my denominator, as I was meant to, and I've got 2x squared minus 20, so my value of a is 2 and my value of b is 20. I could state it like that, but don't need to. Just need to make sure it's in the right form. So 2x squared minus 20 over x squared minus 4. Question 26, here's a sketch of y equals x squared. The minimum point of y equals x squared is at 0, 0. Write down the coordinates of the minimum point of y equals x squared plus 2. Okay. Now, if you've got an equation y equals x squared and you translate it 2 units up by adding on 2, you're going to translate every point up by 2. So this point here that was at 0, 0, adding 2 is going to be a 2-unit translation upwards. So it's going to go to that point there. So my 0, 0 is going to get translated up. It's going to be at 0, 2 then, isn't it? Okay, so that is going to be 0, 2. Okay, the graph y equals x squared is reflected in the x-axis. Write down the equation of the graph after this transformation. Okay, well, a reflection in the x-axis is just negating the equation, isn't it? So y equals x squared becomes y equals minus x squared. And then finally, y equals x squared is now transformed to give y equals x plus 3 all squared. Describe fully this single transformation. Right, now this time we're adding within the brackets. So it's not a translation in the direction of y. This time it's a translation in the direction of x. And how far do we go? Well, when you add inside the brackets, it always goes the opposite direction, as you might think. So if it's positive 3 inside the bracket, then it's actually going to be a translation of negative 3 units to the right, or 3 units to the left. Now, AQA are very particular about how you write this down. They want you to write it using vector notation. Don't really accept any other alternatives. It's not the same with other boards, it's just what AQA like. So we're going to say this is a translation of using vector. So we're going 3 units to the left, so that is the x coordinate is going to be minus 3 then, isn't it? So it's going to be translation using vector minus 3, 0. 3 units to the left using that translation vector. Okay? Yeah, so yeah, AQA a little bit sticklers for these things. Has to be a vector. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.